In this problem, we're asked to find a point on the parabola y is equal to x squared that will minimize the distance between that point, we'll just call it x comma y, and this point 57 comma 0. So we're looking to minimize the distance between here. And we'll find the point on the parabola that does that. So we're trying to minimize the distance function. We know then that the distance function is given as the square root of x minus the other x value, 57 squared, plus y minus the other y value, which is 0. We'll square that. So the function that we are trying to maximize, is the square root of the quantity x minus 57 squared plus y squared. Now we could just take a derivative with respect to x, but this problem is we have the y squared here. But that's no problem because we know y is equal to x squared, so we can substitute that in, and in the end we'll get that the derivative, or the distance function that we're going to take the derivative of, is x minus 57 squared plus x squared squared is x to the 4th. And if you want, you can rewrite this as the quantity, let's see, so x minus 57, we'll square that, plus x to the 4th, but we could write that as the 1/2 power, so we can apply the power rule, and of course we're going to have to chain. So the derivative with respect to x, or d prime, will be, using the power rule, 1/2 times the quantity x minus 57 squared plus x to the 4th to the negative 1/2. Then we take that times the derivative of the inside function. We'll do this one first. The derivative of this is 2 times x minus 57 plus the derivative of this one, which is 4x cubed. So this is the function that we are going to want to set equal to 0. So we could rewrite this as the fraction d prime is equal to 2 times x minus 57 plus 4x cubed over 2 times the square root of x minus 57 squared plus x to the 4th. Set that equal to 0. When we set that equal to 0, that will become 0 when the numerator is equal to 0. So 2x minus 57 plus 4x cubed equals 0. And just doing some simplification, that becomes 4x cubed plus 2x minus 114, and that equals 0. So the easiest way to solve this, to find out where this happens, is to graph it. And if you graph it, you'll see that there is one point where it's equal to 0, and that happens at 3 comma 0. So the value that we will use that solves this equation is x is equal to 3. And then we can evaluate, so this is our critical value, so then we can evaluate the distance function at our endpoints. Well, the distance from 0, between 0, 0 and 57 comma 0 is just 57. In theory, we could go, the distance could go out to infinity as we pick values of x or on the parabola that are way, way up, way up. They're just very further out. So as we keep picking values of x out further, there is no endpoint. There's, in theory, infinity, which is not a good point for us. So in fact, if we take the distance and we go take it at 3, what we'll get is the square root of 2,997, which is approximately 54.74. So 3 is the value that minimizes the distance.